dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to our second lesson on probability tree diagrams. In the previous lesson, we discussed probability tree diagrams with replacement. Now, this lesson we will see probability tree diagrams without replacement. What does this mean? It means when you make the first draw, you don't take back what you have drawn. So that means that the numbers go on reducing the balance of your sample space. They keeps on reducing. And straight away we will move to some problems involving the probability tree diagrams. In this example, we are told the bag has 5 red marbles and 3 green marbles. Mohammed picks a marble out of the bag, notes its color. You see now? This is the important statement. Mohammed does not replace. So if he takes 1 marble, the total will reduce. Instead of being 8, will become 7. So you will see that when we are drawing the probability tree diagrams, the totals are changing. The numbers will change from the first draw to the second due to this fact here. He does not replace. After that, he takes a second marble. So just like what we did last time, we will make 2 sections for the first draw and for the second draw in our probability tree diagram. Okay? So we are told he has reds, there are 5, and the greens are 3, a total of 8. Now I'll put 2 sections for the first draw and for the second draw. This section is for the first draw. This one is for the second draw. Now when he draws the first time, we have 2 options. He could either get a red or a green marble. Okay? He can get red or green marble. Now, what is the probability that he gets a red marble? Yeah? So here, probability of red will be the number of red, then divide it by the total. The total of marbles is 8. So you say 5 divided by 8. Then probability of green will be 3 divided by 8. This is during the first draw. If he is to draw a second time, still 2 options here. Okay, so he could get red, another red, green, red, green. Now let us understand, this is conditional probability. When you are here, let me first mark this part. When I'm here, it means that he took red during the first draw. So if you take 1 red from here, the total will reduce and become 7. And then these reds will become 4. So what does that mean? It means that from here onwards, you have 4 reds and 3 greens. So the probability of red now during the second draw will be 4 divided by 7. Because you have taken 1 red from here and you didn't put it back. So the number of reds are now 4 and greens have remained 3. So this becomes 4 over 7. And then the probability of green will be 3 over 7. If you are here, what does it mean? It means that the first time you took a green marble from that box, if you take a green marble here and you don't replace it, they remain 2. So that means that you have 5 reds and 2 greens. So when I'm drawing the second time here, this probability will be 5 over 7 and this will be 2 over 7. So this is how you deal with problems involving no replacement. And definitely here now, if you need probability that first time you got red, second time he got red, that means probability of R and R. You just multiply these times that. So you'll say 5 over 8 times 4 over 7. If you need probability, first time he got red, second time he got green, which we can represent like this. So you multiply 5 over 8 times 3 over 7. And so on and so on. You can fill the whole table, the whole tree diagram. This one is 3 over 8 times 2 over 7. You multiply and fill the whole probability tree diagram. This is how you do a probability tree diagram where there is no replacement. The numbers go on reducing depending on how many times you have drawn. This is our tree diagram. Now let us see the question. The question, I will guide you. You can refer to this and do your calculations. Okay, so using the probability tree diagram we have on the previous slide, we can answer this question. Here we need probability of getting 2 reds. Probability of getting, let me try to go back. Yep. So probability of getting 2 reds, sorry for that. You go back to that probability tree diagram, you look where we have R and R. Okay, I think you recall we had, this was 5 over 8 and this was 4 over 7. So here you need to find probability of R, which is 5 over 8 times 4 over 7. Okay, then we get our answer. I think it would be 5 over 14, something like that. That would be the probability of getting 2 reds. Then probability of getting same color, probability of R and R, plus probability of G and G. This one we have found it as 5 over 14. You also need to find this one, probability of 2 greens. Go to your to the probability tree diagram, look at that part where you have G and G. I think the first one was 3 over 8, and then the next one is 2 over 7. So you multiply these two numbers to get this probability of green and green. So I'll say 3 over 8 times 2 over 7, then you add, and then you sort out. Now, you put this into the calculator, you get your answer. Probability of getting marbles of the same color. This one, you need to know that same color and different color are complements. So when you add their probabilities, you get 1. So here you will say probability of getting different colors will be 1 minus probability of getting same colors. Okay? So your answer you have here, put it here, subtract from 1, and you have finished this question. You have solved the problem. This is how we deal with this problem. Now, we have another question. Still, it is involving no replacements. So in this example, we are saying there are two groups, Group C and D. Group C has 6 girls and 8 boys. Group D has 3 girls and 7 boys. So a team is made by picking at random one child from Group C. So you first pick from Group C, which has this. After picking here, then you go to Group D. You choose also from Group D, and these are the members of Group D. So complete the probability tree diagram, which follows, which is on the next page. Okay? So to answer this question, remember in Group C, we have 6 boys, and we have not 6 boys, we have 6 girls and 8 boys. That's what we have in Group C. So if you're choosing from this group, probability of getting a girl will be 6 divided by the total, which is 14. Probability of a boy will be number of boys, which is 8 divided by 14. That's how you get these probabilities here. Then you could do the same here. Group D, if I am not mistaken, I think we had 3 girls and 7 boys. That's what we had. So if you need probability of a girl from Group D, it will be 3 over 10. This will be 7 over 10, 3 over 10, 7 over 10. Then you do the needful. Let me first erase this. Okay. Now, what is the probability of getting a girl and a girl? Probability of G and G. So you multiply this 6 over 14 times 3 over 10. That gives you the probability of getting 2 girls. Probability of getting a girl and a boy. First time girl, second time boy. This will be 6 over 14 times 7 over 10. Probability of getting a boy and a girl will be 8 over 14 times 3 over 10. And then lastly, probability of a boy and a boy. So here you're getting 2 boys. So you have 8 over 14 times 7 over 10. You have completed your tree diagram. Now let us see what the question needs from us. Before we do that, we'll need to work out the probability that there are 2 boys in the team. You see? Yeah, so to get the probability of 2 boys, it means, so you go back to the probability tree diagram, you see where you have B and B. Multiply those 2 and the problem is sorted. So this brings us to the end of our lesson, and see you next time.